In this problem, three natural numbers are given and these numbers are A, B and C. We have to find the number of ordered pairs of ABC that satisfies the following condition. And the condition is 2 raised to the power A plus 4 raised to the power B plus 8 raised to the power C is equals to 328. Now if you see, this 2 is an even number, 4 is an even number and 8 is an even number. In fact, right side also I have an even number. 4 can be written as 2 square, 8 can be written as 2q. So I will use this idea to solve this problem. So this is the problem. So we have been given this condition. Now we can write 4 as 2 square and 8 as 2q. Now if you remember, if I have something like this, a raised to the power m raised to the power n, this can be written as a raised to the power m times n. So here I have 2 square and raised to the power b, this is same as 2 raised to the power 2 times b. Similarly here I have 2 raised to the power 3 raised to the power c, this can be written as 2 raised to the power 3 into c. And this is equals to, right side we have 328. Now let us say these three numbers, that is A, 2b and 3c. So this is a set that is unknown. Let us denote this with another set PQR, and this P can be anything. P can be A or 2b or 3c. Similarly, Q can be anything. It can be A, 2b or 3c. Same with R. This means these three numbers are not in order as written here. Now furthermore, we can assume that any one of the number is a smallest number and any one of the number is the largest number. Without loss of generality, I can assume that, let's say, P is the smallest number and R is the largest number. So P is less than equal to Q and Q is less than equal to R. Now let us see this identity, that is 2 raised to the power A. Now A can be, so 2 raised to the power A, 2 raised to the power 2b and 2 raised to the power 3c. So this is what? This is 2 raised to the power 2 raised to the power 2 raised to the power. So any one of them can be 2 raised to the power P, any one of them can be 2 raised to the power Q and any one of them will be 2 raised to the power R. So this can be written as 2 raised to the power P plus 2 raised to the power Q plus 2 raised to the power R, and this is equals to 328. Remember, P is the smallest. So I can take 2 raised to the power P common. So what is left? Here I will have 1. Here I will have 2 raised to the power Q minus P. Here I will have 2 raised to the power R minus P, and this is equals to 328. Now 328, this can be written as 8 into 41 and 8 can be written as 2q, 2 raised to the power 3. Now if you compare, here you have 2 raised to the power 3 and here you have 2 raised to the power p, and this is, here we have 41. So now I can compare. So this term is equal to this term. Similarly, this term inside the bracket is equal to 41. So if I compare, I can say 2 raised to the power p is equals to 2q, this means p is equals to 3. So we have solved for one unknown p. Now this one is equal to 41. Now if I take 1 to the right hand side, I will have this and this term, and this is equals to 41 minus 1, that is 40. So this is the condition now we have. Now I can take 2 raised to the power Q minus P common because Q is the second smallest and I am subtracting P here as well as here, so it does not matter. So this is the smallest number. So I can take 2 raised to the power Q minus P common. So what is left? Here I will have 1 and here I will have 2 raised to the power R minus P, and then subtract this power, that is minus Q plus P. So P and P cancels out and R minus Q. So this is 2 raised to the power R minus Q. And for T I can write 8 into 5 and 8 I can write 2 raised to the power 3. Now once again same situation. I can compare this part with this part and I can compare this part with this part. So if you compare, you can say 2 raised to the power Q minus P, this is equals to 2Q. This means what? Q minus P is equals to 3. But we already know the value of P, so I can plug P is equals to 3. So this becomes Q minus 3 is equals to 3. This means Q equals to 6 because I can take this 3 this side. So 3 plus 3, so Q is equals to 6. Now the second component, that is now I can compare this part with 5. That is 1 plus 2 raised to the power R minus Q. This is equals to 5. Now I can take 1 to the right hand side. So this becomes 2 raised to the power R minus Q. This is equals to 5 minus 1, that is 4. And 4 I can write as 2 raised to the power 2. I can again compare R minus Q and this is equals to 2 because if the base is equal, exponent has to be equal. So R minus Q is equals to 2. But we already know value of Q. Q is 6. So R is equals to, I can take this to the right hand side. So this becomes plus. So R equals to 8. So now we have solved for PQR. So P is 3, Q is 6 and R is 8. You can check this condition is still satisfied, that is P is less than equal to Q and Q is less than equal to R. This means R is the largest number and P is the smallest number. So now I know the solution set, basically the PQR mapped with A, 2B and 3C. So this is 3, 6 and 8. So any one of them can be 3, any one of them can be 6 or any one of them can be 8. Now we have 3C. So 3C can be either 3 or 6, it cannot be 8. So for 3C I have possibility, it can be 3 or it can be 6. Similarly for 2B, it's an even number. It can be either 6 or it can be 8. So what are the possibility? So if 3C is 3, then I can have 2B is either 6 or 2B is 8. Once I have 3, 6, then other number will be 8. I have 3 and 8, then other number will be 6 because the three numbers are 3, 6 and 8. So we have done 3C is equals to 3. What about when 3C is equals to 6? So when 3C is equals to 6, I can have 2B is equals to 8 and then left number is 3, or I can have 2B is equals to 6. But that is not possible because I have already considered 3C is equals to 6. So this is not possible. So only 3 cases are possible, that is first 3 cases. Now in each case, I know the value of A, B, C, A, 2B, 3C and then I can calculate value of A, B, C. So these were the first 3 cases. A is equals to 8, 2B is equals to 6 and 3C is equals to 3. So when A is equals to 8, I have A is equals to 8. 2B is equals to 6 means B is equals to 3. 3C is equals to 3, this means C is equals to 1. Second situation, this will be 6 and this will be 4 because 8 divided by 2, that will give the value of B, and this will be 3 divided by 3, that is 1. Now in this case A is equals to 3, B is equals to 8 divided by 2, that is 4, and C is equals to 6 divided by 3, that is 2. So these are 3 possible solutions in this case. So this is the first set of solution, A is equals to 8, B is equals to 3 and C is equals to 1. This is second set of solution, A equals to 6, B is equals to 4 and C is equals to 1. Similarly, the third set of solution is A is equals to 3, B is equals to 4 and C is equals to 2. So for this problem, there are 3 solutions that are possible. And I hope you like this problem, and if you like my videos, Please share with your friends, like on my channel and subscribe to my channel. I will see you in the next video. Thank you.